Welcome to the MS SQL Tips webcast. Ask the Expert, live Q&A about high availability in the cloud for SQL Server, sponsored by SIOS Technology. I'm Greg Robity, co-founder of MS SQL Tips and today's webcast host. Joining me today is Dave Birmingham. Dave is a Microsoft Cloud and Data Center Management MVP with extensive experience of working with SQL Server in clustered environments and cloud implementations of SQL Server. Today, he will take your questions related to moving SQL Server to the cloud and protecting SQL Server in the cloud with options for disaster recovery and high availability. To submit a question, use the question area in your presentation controls, and we will try to answer as many questions as possible during today's webcast. If you have any technical issues with the sound or screen quality during the webcast, also use the question area to let us know. If you're not already a member of the MS SQL Tips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. We want to make this session as interactive as possible, so please ask questions that you would like to get answered. Once again, use the question area in the GoToWebinar controls to submit your questions. I'll let Dave introduce himself, and then we have two quick poll questions that will give Dave a sense of your experience with the cloud. So Dave, you want to just talk about yourself real quickly, and then we'll do the polls and get to the questions.
Yeah, thanks, Greg. So, as Greg mentioned, my name's Dave Birmingham. I've been a Microsoft MVP for 6 years. Traditionally, my expertise has been in high availability failover clustering with a focus on SQL Server and clouds such as Azure and AWS, and recently been transitioned to this new Microsoft Cloud and Data Center Management MVP designation. I've been an employee of SIOS Technology for 12 years now, where as a technical evangelist, my sole focus really is on helping customers plan and configure high availability and disaster recovery solutions for their Windows servers. So that's been my focus for 12 years. So that's primarily why I have the expertise in the cloud and high availability. So I think, as Greg mentioned, he has a couple of poll slides we want to pull up real quick just to get a feel for what you're currently doing in the cloud, and so I can kind of focus my discussions around the areas that interest you most. So, Greg, you want to go ahead and put up the first poll question?
Yep. All right, put that out there. So everybody can just take a couple seconds to answer this. So how do you currently use the public cloud? I got a bunch of people have already responded. Just give us another 30 seconds, and then I'll read the results, and then we can do the second poll question.
While you're thinking, answering the poll and thinking about some questions you may have, we have a couple questions we've been asked ahead of time. We'll start with just to get the conversation going, but yeah, don't hesitate to put your questions in the question window there. We'll be sure to answer as many as we can.
All right, I'm going to close this and I'll share the results. All right, so we have 57% said they do not currently use the cloud, 22% use it for test and development only, 20% they have a hybrid, both on-premise and extended the cloud, and 2% so they've replaced the traditional data center.
All right.
All right, and then we'll take a look at the other poll real quick. And this next poll is, which cloud provider do you use? So anybody that's using the cloud, if you can just let us know about this. Do the same thing, just let this go for about 30 seconds. We've got a good amount of people have already voted. All right, another 5 seconds, we'll close this and I'll share the results. All right, let me share this. So 52% said none, 29% Microsoft Azure, 16% Amazon Web Services, and 3% said other.
Okay. Yeah, that makes a lot of sense from what I'm seeing out there. Azure has really come on strong, even though Amazon's been out there for a few years longer. it looks like Azure's gaining the market share there. So that's kind of jives with what I'm seeing as well. All right, so that helps me, focus my, the answers to my questions. It sounds like, about half of you haven't done much in the cloud yet at all, and then only about 20% of you or so are using it in any sort of fashion other than test dev. So that's good to know. I see the cloud really in the opportunities coming through SIOS. Through the years, I've been here 12 years, like I said, started with before the virtualization phase, right? It was all physical servers, clusters in a box with SCSI, shared SCSI disk, and then we moved into blade centers, and then virtualization took over like wildfire, and we saw that come in, and within a matter of 5 years, go from, like I said, the test dev that we're seeing people use in the cloud now to being the standard deployment, virtualization first, physical servers only when absolutely necessary. I think from what I'm seeing, the cloud is in that same, beginning middle phase that virtualization went through, where test and dev, it's great, it's obvious, makes sense, and as people get used to the cloud and that environment, they're moving now their business critical workloads to the cloud, or you're leveraging the cloud as a disaster recovery site. And by doing that, it's important that you plan for the same level of availability that you've used for years on-prem in the cloud. And so that's really the focus of this session. It's live. Submit your questions and anything that you have a question about. Hopefully I'll have an answer for you. Focused on high availability in the cloud for SQL Server. So, Greg, if you want to start feeding me some questions, we'll get going, and keep the questions coming. We'll go for the whole hour if we need to.
Okay, sounds good. Yep, we have a couple questions already. So I'll just throw these out there. You can answer these are not necessarily high availability, but one question is, what's the difference between SQL Azure and cloud for SQL Server? Kind of just hit that framework.
So in Azure, Microsoft has something called Azure, which is a suite of cloud services. And they have something in Azure SQL Server, which is essentially think of it as a software as a service or platform as a service that they actually host a SQL Server instance that you could build to. So you could, build your applications around their hosted instance of SQL Server. And in those cases, it has its advantages, but it certainly has its limitations as well, because you're not actually managing the SQL Server instance, so it doesn't support all the features that you might be used to, when you manage your own SQL Server deployment. But something certainly to consider. What we're really focused on are the people that are using, instead of the SQL Server Azure SQL Server, we're focused on people that are leveraging the Azure infrastructure as a service. So the ability to deploy your own virtual instances on the Azure platform, and then deploy SQL Server within those instances. And that gives you the same flexibility that you have today with your on-prem instances, because essentially it's your server. You can do what you want with it, and you manage SQL Server. But the one thing you need to understand is now you are responsible for that SQL Server. You're responsible for its availability, and simply by putting it in the cloud on a single instance does not make it highly available. Certainly doesn't make it highly available. So we can, we're just pretty much the focus of this is how can we go from that single instance of SQL Server in Azure and make it now highly available. So maybe I'll just kind of build off that question and probably cover a lot of other questions with this initial discussion here. So when you're deploying in the cloud, you might read the SLAs that the cloud provider says, oh, it's 99.95% available, and I think that holds true for both Azure and Amazon. Will quote those service level agreements. Well, if you read the fine print, there's some work on your end in order to take advantage of that 99.95% of availability. And what it comes down to is they're only guaranteeing that 99.95% of the time one of your instances will be available if you deploy multiple instances in different locations within their cloud. So when I say location, if we're talking about Amazon, Amazon has data centers in different geographic locations across the world. But within each of those locations, there are availability zones. So for instance, in Azure, Amazon, on the East Coast, you might have an availability zone 1, 2, and 3. So there's three different zones within the same region. And to qualify for the service level agreement, you must have at least 2 instances running in different zones within that region. In Azure, those regions are called fault domains. And so in order to make sure your SQL Server is highly available, you have to have 2 instances, one running in one, we'll just, for the sake of ease of discussion, we'll just call them fault domains. So you have to have SQL running in one fault domain, another instance in another fault domain. And what the cloud provider is guaranteeing is that at least one of those instances will have what I call dial tone, that you'll be able to ping that instance and it will respond. But if you think about it, that makes sense for web servers or application servers where the data is static and you can load balance across multiple instances, because you can just put up many instances in different fault domains and put a load balancer in front of that, and one of those instances are going to respond. And so that gives you your high availability for your your web servers and any application server that can be load balanced in that fashion. But SQL Server is not a application that can be load balanced so easily. Instead, you have to plan for some sort of failover between the instances, and you have to account for some sort of data replication between the instances to ensure that each instance has an up-to-date set of data, so that if one fault domain goes away, another fault domain is going to be able to continue to function and answer the queries that are being sent to it. So to do that, you have to rely on your traditional SQL Server high availability features, which today the features are SQL Server AlwaysOn availability groups, which gives you the ability to do replication at the database level between different SQL Server instances, and failover, leveraging the failover clustering and client redirect there. So that's one option. That requires the SQL 2012 Enterprise Edition or higher. So you have to have the Enterprise Edition of SQL Server in order to take advantage of that. The other main high availability feature is SQL Server failover clustering. And traditional failover clusters require some sort of shared storage device where all the databases and log files reside. In the cloud, you don't have the concept of a SAN that is a single point that you can store all of your data. All the data is stored locally on each instance. So in order to build a failover cluster in the cloud, you're going to have to use a third-party solution like SIOS Datakeeper Cluster Edition that's going to be able to keep the data in sync across the different fault domains, but still integrate with failover clustering to give you the failover features that you might currently have deployed today on premise, but do that in the cloud using just the local attached storage or something called a SAN-less cluster. It gives you high availability. Benefit of that solution is failover clustering is supported in SQL Server Standard Edition, so you're going to be able to take advantage of the cost savings of deploying SQL Server Standard and still have the high availability failover clustering that you have today on-prem, but using local attached storage in that SAN-less configuration. Other options that you can consider, SQL Server database mirroring has been deprecated. It's still available in SQL Server 2012 R2, but again, you're limited in Standard Edition to synchronous only. So it might be good for you might be able to leverage it for local failover within the same region. But if you're looking for disaster recovery, you still don't have a great solution because there's no asynchronous replication option available. You get asynchronous with always-on availability groups. You can, or with the SIOS Datakeeper, supports synchronous and asynchronous. So you can have a mix of synchronous for local high availability and then asynchronous if you want to replicate a greater distance. And that's something else to consider in the cloud. You have high availability within the same region, but what about disaster recovery? What if an entire region goes dark? And that has happened. It's not supposed to happen on a regular basis, but you really have to plan for all contingencies. So you want to probably in your plan, you want to account for having some sort of plan B, for disaster recovery if the entire cloud goes out to lunch. You don't want to be held ransom by Microsoft or Amazon. You want to be able to recover your data and get your applications back up and running. So in any cloud configuration, you should definitely plan for a way to keep your data replicated off-site, outside of the cloud as well, maybe back to on-prem or to even leveraging 2 different cloud providers for that. So let's take some more questions and we can expand on some of that as we'll see where the interest lies.
So you might have answered some of this already, but the question is, what configuration would you recommend providing HA, this is for SQL Server 2014 Standard Edition, leveraging the cloud, but they still want to use their on-prem servers, but then use the cloud for either failover or if they're patching to have that server come up. So can you kind of talk about what kind of options are available to do something like that?
Yeah, so SQL Server Standard Edition is there's limitations, right? So SQL Server Standard doesn't give you the always-on availability group, so that's not an option. It does have database mirroring, but it's limited to synchronous only, and so that's not really an option to replicate on-prem into the cloud due to the latency of the bandwidth. Would have a negative impact on the performance of your primary servers. And then also in the cluster configuration, SQL Server Standard Edition has has the limitation of only being able to support a 2-node failover cluster. So reading between the lines here, if you're talking about deploying a SQL Server cluster on-prem, but then leveraging the cloud as also a failover partner, you're going to have to look at, you're not going to be able to add the cloud as a 3rd node into the cluster because of SQL Server Standard only supporting 2 nodes. You will be able to leverage Datakeeper Cluster Edition to replicate asynchronously to the cloud for data protection only. So even though you can't build a 3-node failover cluster, you can add a 3rd node as a replication target, and so you still have a asynchronous target for your data. So the cloud will have an up-to-date copy of your data in the event of a disaster. And what you would do is in the cloud, you could deploy a standalone instance of SQL Server, and in the event of a disaster, you would then mount the replicated databases and redirect your clients and applications to that cloud instance. But that process would have to be some sort of manual process or some scripted process that you would have to call in the event of a disaster. To leverage a cloud in that sort of configuration for failover for simple patching is probably not ideal. If you really wanted that level of automation, then you would probably want to look at the SQL Enterprise Edition to make it a true 3rd node in your cloud. And typically moving your SQL Server instance from on-prem into the cloud is, there's other considerations. Is where do my clients sit that that hit that database, and if I move it from on-prem to the cloud, now if I have clients that still reside on-prem and they're hitting the database in the cloud, how does that impact the performance of the application? So, many times the cloud is looked at as a disaster, part of, as a disaster recovery site, but the plan to move to the DR site, moving SQL Server and activating it in the cloud is just one part of the plan. You have to consider what are you going to do for your applications and your clients as well. So that's all part of your disaster recovery plan.
Okay. And this next question, Dave, is more, I guess, sort of generic in sense. The question is, what are some of the performance benefits moving to the cloud? But if you can kind of maybe expand upon that, performance, security, high availability, just if you can kind of quickly talk about, because I know a lot of people said they haven't done anything with the cloud yet, so maybe give them some reasons why the cloud is actually a good option.
Yeah, so I mean the cloud is great for people who are looking to, one of the benefits of the cloud is it's extensible. So if you, for instance, common use case scenario, if you have a online web store and you do 90% of your business leading up to the holiday season, you don't need all this 20 front-end web servers and super powerful back-end servers, because 9 months out of the year they're sitting idle and you're still paying for the for that service. The cloud is perfect because you can you can ramp up the number of servers, so you can scale out so that you're prepared for that holiday season, but you don't have to pay for those services all year round. You just pay for the services as you need them. So that's that's your typical use case of the cloud, is to be able to rapidly scale out and add new resources without adding additional racks in your data center, or going through the whole purchasing process, because the cost of the cloud is not going to be a capital expense. It's going to be a monthly recurring expense. So it's easy to just get what you need on demand, and no more, no less. And then when you're done, you just turn it off and you stop paying for it. So it's very easy. As far as performance benefits, I can't say there's a performance benefit per se. You can certainly buy servers on-prem that are going to be screaming fast. You leverage flash storage and the latest and greatest of everything, and you're going to be able to build some incredible servers. And cloud, they can't do any more than you can do on-prem. And typically you're sharing those resources, although you can get dedicated resources. So there's no built-in performance benefit. However, there's no limitation. I mean, pretty much the cloud gives you just as much as you need, no more, no less. The more money you spend, the more resources you can utilize. So in Azure, they added something called premium storage, and so if you need more IOPS, where today, if you have a SAN that your company spent $500,000 on last year and it was fine at the time, but all of a sudden your workload has grown 3 times. You acquired some, a company and all their customers, and all of a sudden now your $500,000 or $1 million investment in the SAN no longer meets your IOPS requirements. To fix that problem is a very expensive proposition. It's pretty much, you can only upgrade your SAN to, add so many spindles to increase the storage, and before it doesn't make any more sense. You just buy another SAN to meet your needs. In the cloud, you can just, add more disk and increase, just pay for more processing power, more RAM, more disk, whatever it might be, and scale up as you need to. So it's very easy, again, to address those unforeseen needs that might crop up.
All right, great. Let's see, the next question, Dave. let me just kind of read what they've wrote here. So basically they're saying is that management's pushing them towards moving to the clouds. They've had some problems with downtime, and their management team is saying, go to the cloud, everything will be taken care of. You don't need to worry about HA, performance, any of that stuff. Can you kind of just talk about, is that really the case that once you go to the cloud, one of these providers, they take care of everything, or are there still things that you really need to worry about and should be concerned about?
Yeah, like I said early on, the headline says 99.95% SLA, and so that's all the CEOs and all the managers. That's what they read, and then they say, "Go get us some of that," And but you start digging in a little bit deeper to even achieve that SLA. It's going to require the planning. Like I said, take Azure as an example. Azure will say 99.95% SLA, but that requires that you deploy in at least 2 or more nodes in what they call an availability set. By putting it in that availability set, it distributes those nodes in different fault domains. Now, in Azure, there's 2 concepts. There's something called a fault domain, and there's something called an update domain. If you've looked at Azure at all, those terms are probably familiar with you. And I'll tell you what the difference are. Fault domain is for unplanned downtime, where an update domain is for planned downtime. Now, just because you're in the cloud doesn't mean that you can forget about planned downtime. Someone has to apply patches to the servers, and so there's going to be downtime associated with with your cloud deployment. So think of it like this. A fault domain is a rack of servers, and so there might be 8 servers in that rack. Now, and that rack has totally independent power, networking, storage, obviously the servers. So there's no single point of failure between that rack of servers, which is a fault domain, and another rack of servers in the same region that is another fault domain. And so you definitely want to have one instance running in one rack and one instance running in another. And by putting it in putting it in an availability group, it makes sure, availability set, it makes sure that you have one instance in each fault domain. Now for update domains, obviously if you're in different racks, you're going to be in different update domains. So you think of an update domain as a subset of fault domains. So each one of those individual servers in that rack could be an update domain. So you might have 8 update domains per rack. Now, Azure limits you to a total, if you're using the new Azure Resource Manager deployment model, it limits you to a total of 3 fault domains. So the most you can do is if you put 3 servers in an availability set, you'll have one instance in 3 different fault domains. And that's great because a typical cluster, you're going to want to have one node in one fault domain, the other node in another fault domain, and they're going to have to leverage a file share witness. If you're familiar with clustering and cluster quorum types, you need a witness. And without a shared disk, you're going to leverage a file share witness. So by putting that file share witness in that 3rd fault domain, that gives you redundancy across the 3 votes in your cluster. Now, update domains, Microsoft guarantees that they will only bring down one update domain at a time. So if they're doing planned maintenance, they will only work on one server in that rack, take care of that, and make sure it's back up and online and running before they bring down the next server to apply the updates. So that also protects you from planned downtime. If they reboot the server that's your active cluster node, it'll fail over to your backup cluster node and make sure your application keeps up and running. There are numerous update domains. I can't even recall the number, but there's 20 or more update domains that you can leverage in an availability set. So if you're deploying, for instance, a web farm, you put all your web servers in the same availability set. That's going to distribute your web servers across multiple update domains, so that you only ever lose, say you have a farm of 20 web servers, you're only going to lose one at a time, and the load balancer will make sure that the load is distributed to the rest of the web server. So to answer your question, yeah, cloud is good, but it's only, you still have to leverage the same techniques and technology that you've used on-prem to make sure that your servers are highly available in the cloud. They're not gonna do that for you. You have to make sure you understand what you're signing up for.
All right, next question, Dave, is what SQL options are there for on-prem along with the cloud for disaster recovery? So some of the things they threw out here are like replication, always-on availability groups, clustering, backups, log shipping. Can you kind of just talk about what things they can do for DR for keeping on-prem and then putting something actually in the cloud for those other pieces?
Yeah, it really all comes down to it. Everything they mentioned there are viable options when you think about disaster recovery. The first thing when you're doing disaster recovery planning is you have to identify your recovery time objective, or RTO, and your recovery point objective, or RPO. So you have to know how much data can your company withstand losing in the event of a total disaster, like smoking crater type disaster, and then how fast do you need to get things back up and running. And then that will, once you define those, that usually eliminates some of the options that were mentioned. So you go with the low end, you think we can do backups and ship them off site. I mean, traditionally when I started in IT, that's we did tape backups, and we did a full backup weekly. We sent that off site, and we did daily incremental backups, which were not sent off site. And so the company was okay knowing that if the building burnt down, they may lose everything that happened this week, and the best we could do is restore it to last Friday when the backup tape was sent off site. And that could be fine in some situations. Most companies aren't going to be very happy with that. So now you look at the cloud. Well, so we can do the same type of thing. We can do backups every day, and now there's technology. We can ship those backups off-site, connected to the cloud, and even have standby servers ready to restore those backups, so that you can be back up and running as well. But you're still basically your recovery point objective is, well, how up to date is the last backup that is actually made it off-site. And that holds true for all those solutions. So obviously log shipping has been around forever. So you can get the data off-site in asynchronous fashion to replay those logs and get you back up to speed. It could take some time, so that's going to impact your recovery time objective. Now database mirroring, transactional replication, all those things are also options as well for you to look at for getting your data off-site. So you have to understand the limitations involved with each of those, and what's going to work for you and what's not going to work for you. The more robust solutions out there are going to be, for the best recovery. If you think about recovery time objective, if your recovery time objective is measured in minutes, then you're going to want to look at some sort of automated failover solution. And that really limits your options to the always-on availability groups or the always-on failover clustering. And as we mentioned before, the always-on availability groups is going to let you define, if you have SQL Server Enterprise Edition, it'll let you define which databases you want to replicate off-site. And we can replicate those databases off-site asynchronously. Now, for automatic failover, you're going to have to do synchronous replication using availability groups, and so that's generally not an option for disaster recovery. So you're still going to have to push the button for failover to the DR site. If you leverage Datakeeper Cluster Edition in a SANless cluster, so a failover cluster instance, you can use asynchronous replication and still have automatic failover enabled. But what that means is that your recovery time objective is more important than maybe your recovery point objective. Because if you have automatic failover enabled with asynchronous replication, what you're saying is you're okay with possibly losing, a few writes, but getting things back up and running is more important than ensuring that you don't have any sort of data loss. But you can do that with the SQL Server Standard Edition and have disaster recovery with pretty much the best recovery time objective or recovery point objective you can expect for any disaster recovery solution.
All right, let's see. The next question, Dave, is something you mentioned earlier about some load balancing. They're just wondering, are there any load balancing options in Azure? And then maybe kind of follow up with that with even like high availability, they have really highly used systems. I know you talked about throwing more resources at it from the cloud, so maybe kind of talk about that as to what options there may be.
Yeah, so there is no, there's no magic bullet for load balancing SQL Server, and there's nothing you can do to scale out SQL Server per se. You can't add more nodes to a high performance cluster in the SQL Server world. So you're really looking at scaling up, and in Azure they have some pretty, if you look at the different instance sizes, there are some pretty significant resources available to you, even dedicated resources available to you. So you're really not, the cloud's not limiting your options, but then again, it's not giving you any options that you don't have today on-prem. So there is no magic, load balancing option that you can, add multiple instances and load balance across. Speaking of load balancers, though, in Azure you will run into the load balancer as a requirement. The way that Azure does the client redirection, if you've looked at any of the documentation, and this holds true for both the AlwaysOn availability groups as well as AlwaysOn failover cluster instances, is Azure networking stack does not support gratuitous ARPs. And so what that means is that you cannot connect directly to a clustered IP address in Azure. And the way that Azure would have you redirect your clients is to create a load balancer in front of your cluster. And a load balancer is probing the nodes in your cluster to see which node is active. And then your clients connect to the load balancer, and then the load balancer redirects your connection to the active cluster node. So I just throw that out there in case you're looking at Azure right now, or you're fooling around with it and you can't figure out why your clients aren't connecting. There's a lot of documentation out there, and I'm gonna pull up a slide here so you can get some more information here. On my website, Clustering for Mere Mortals is my blog. I've written a lot of detailed how-to articles on how to configure failover clustering in Azure and configure that internal load balancer so that your clients can connect upon failover.
All right, the next question, well, basically the question is they're getting, planning to move to the cloud, and they're just wondering how do you evaluate the difference between what Amazon has to offer versus what Microsoft has to offer, and is there any documentation, any articles, things that could kind of help them make the decision of, which direction to kind of move?
That's a tough question. It's been a while since I've done any sort of analysis, so you can look at it a couple ways, right? There's pure price analysis, but you really have to dig in to know, because they each have, it's like any, it's almost like going buy a car. You're like, oh, the price is one thing, but you want, the undercoating, you want this, you want that, and then there's different, they each charge for different pieces, and maybe one person throws in something and the other person, it's an additional fee. Anything from, you have to look at the cost for the storage, and there's different storage options. So you're talking about premium storage or regular storage, and you have to look at the cost of data transfer. What are you paying for ingress, egress, how much, and how is that calculated? and then just pure, horsepower. Like, what am I paying for? What does how does this instance size compare? What's the comparable instance size in Azure to Amazon? And those prices are constantly changing, because you can imagine there's some sort of a price war, but certainly Azure doesn't want to be seen as much more expensive than Amazon, and vice versa. So they're all constantly adjusting their prices. And the good news, mostly from what I've seen, going lower or giving you more for less. And again, I haven't. It's hard. Anything about the cloud is that it changes daily. When you think about a Microsoft Windows release, Windows Server 2012 R2, when did that come out? And we're still waiting for Windows Server 2016 to become generally available. So you're talking about, like, every 2 years you might get a new set of features, and the cloud is completely different, because you might get a new set of features every week, and you might not even know that they're, if you're not following all the latest, blog posts or announcements from Microsoft or Twitter feeds or whatever, you might not even know that something new has been put out there. It's a very, very agile development. They just release features as they become available. And so I guess what I'm trying to say is, Azure has come out with some really incredible, and I think they've claimed to have the most, biggest, baddest virtual machine out there in terms of number of CPUs and RAM and just pure horsepower. But is that what you need? You really need to just look at what resources you require, and like, price comparison is certainly one thing, but then you got to look at, support and community support, and support from Microsoft, and the whole 9 yards. So honestly, I can't. They each have their own. They each have their own quirks, I would say. Amazon's certainly been around for a while. Their interface hasn't changed all that much, as far as I can tell, in quite some time. On the other hand, Microsoft Azure has been changing rapidly over the past year, and they basically released what you might call it Azure 2.0. It's in terms of the infrastructure as a service, they had this thing called Azure. They call it Azure Classic, but it's basically their first iteration of Azure infrastructure as a service. And over this past year, they've totally revamped and introduced something called Azure Resource Manager, or ARM for short. It has more features, more bells and whistles, and that's what they're developing for, that Azure Resource Manager. They totally revamped their portal, which, for a long time, it was in preview, and it could have been a nightmare to use, because there was certainly a lot of bugs. But I've been using it now for the past 6 months, and I love it. So it's hard to say. I'm not going to endorse one or the other. You really have to look at it, and they each have, I believe, some, minimally some trial licenses that you can use. So I would certainly, if I was making that decision, I would be kicking the tires of each, deploying similar workloads and doing some performance analysis, and just getting a feel for what we're comfortable with. They're both, excellent options. It's just something that you're going to have to make a decision based upon your comfort level.
All right, the next question, Dave, is related to high availability options in the cloud for SQL Server reporting services and SQL Server analysis services. Do you have any information on what people do for those services?
It's going to be this really, you still have the same limitations you have on-prem. So there's in Azure, you have access to all the things that you have on-prem. For the failover clustering, you're going to leverage the Datakeeper cluster resource, and to build clusters. But you're not, there's no magic bullets to make those systems more highly available. So I don't have all those details at my fingertips, but I know there's some limitations in some ways to build build availability into those services, and you're just going to have to leverage the same best practices that you would on-prem in Azure.
Okay. This is another just a general question about moving to the cloud, not necessarily HA related, but they're just it's related to security, and just wondering, are there concerns that people should have about security, or has both Amazon and Microsoft really taken care of some of the security concerns that were kind of out there in the early days of cloud usage?
Well, security is always a concern. Whether you're on-prem or in the cloud, you need to be comfortable with the cloud provider, and their security, what they have to say about security. Each cloud provider offers encryption options, so you can encrypt your virtual disk, which gives you some assurance that someone's not just going to pick up your virtual disk and run off with it and be able to decrypt everything. And then there's all the just protecting, setting up security to protect from intruders, just like you have on-prem firewalls. There's firewalls in the cloud that you can configure to ensure that only the traffic you want allowed into your deployment is allowed. So but obviously you got to protect your credentials, right? If someone gets a hold of your Azure account password and they can go in and bypass security. So best practices around securing your credentials will hold true in the cloud as well.
All right, thanks, Steve. The next question, this was asked by a few different people, and there's really two parts to this. So the first part is, will Datakeeper Cluster Edition work in AWS? And then secondly, is there the option to have the secondary be readable only?
So we were talking about Datakeeper for both of those questions. The answer is yes. Datakeeper Cluster Edition can be used in pretty much any cloud platform, including AWS. AWS and Azure each have like I said, their own kind of wrinkles of how things go about. So we have some documentation on our website about deploying clusters in AWS. It's pretty much like deploying a on-prem SANless cluster. The main wrinkle in AWS is, and I found this out early on, the first time I tried to build a cluster up there. It's the same with Microsoft. I built the cluster, everything seemed to be working fine, but none of my clients could connect. I could only connect from the node that was online. And after some head scratching and talking to some people, discovered that you have to add the cluster IP addresses as secondary addresses on each interface card. And so I'll give you the wrinkles between Azure and Amazon. The biggest difference is in the networking. So in the Amazon world, AWS, the availability zones are in different subnets. So every cluster you deploy is a multi-subnet cluster. So they're going to reside in different subnets. So that's not always the best, depending upon your application and how well it handles cross-subnet failover. And then so each node will be in a different subnet, so you have to create a multi-subnet cluster. And so those additional cluster IP addresses have to be added as secondary addresses on the actual the network interface card through the Amazon portal. And so that's one thing you need to know, and it's cross-subnet failover. And as I mentioned in Azure, Azure has different fault domains, but the good thing is all the fault domains, you can configure them to be in the same subnet, which is typically what you're going to want to do, so that failover, is within the same subnet. But you have to leverage the internal load balancer. So there's, some configuration things that have to go on there. And I'd say one of the biggest limitations in Azure today is you can only have one load balancer per Well, I'll tell you what they are. So per cloud service in the Azure Classic, or they call it, you can have one load balancer per availability set in the Azure Resource Manager. But what bottom line is, what that means is you can only have one listener per cluster. Whether if you're using always on availability groups, then that means you can only have one listener, so only one availability group. And if you're doing a cluster, a failover cluster instance, you can only cluster one instance. So you can't have a multi-instance cluster in Azure. So that is a limitation in Azure if you were thinking about deploying a multiple instance cluster, or if you were thinking about deploying availability groups but were planning on having multiple availability groups. You won't be able to do that using the Azure internal load balancer. The only workaround is to leverage the external load balancer, which basically they will allow you to add additional public IP addresses to your load balance set, and then you could have multiple client listeners, but all your client connectivity would be happening across the public internet, rather than using internal addresses. So I throw that out there just as for those people that are trying to figure out which cloud they're going to use. Make sure that you're aware of that limitation there in Azure.
Okay. All right. The next question, Dave, is it possible to set up like a disaster recovery between having servers on Amazon and having servers on Azure?
Yeah, so using the cloud as a disaster recovery site, the typical configuration is hybrid. So on-prem into Azure, and then or on-prem into Amazon. And so there's two things. The two things you need to consider with any disaster recovery is the network connectivity, and then what type of replication you're going to use. So let's talk about on-prem into the cloud first. So if you're going into AWS, you can use AWS Direct Connect, which is a private connection that you can lease, which you can get speeds from 1 to 10 gigabits per second to go directly from on-prem into AWS. And Azure has Azure Express Route, similar speeds, private connection directly from on-prem into Azure, and that's going to be the best. That's if you're going to have any sort of significant traffic, you're going to want to look into one of those private connections from on-prem into cloud. Now, going between Azure and Amazon, you're going to have to leverage create a VPN. So, and you can do that from on-prem to cloud as well. VPN is the other option. So travel across your public network through a VPN connection. But you're going to have to configure that connection, and I've known people who have done that, and I know there's some blog articles out there written about how to configure a VPN between AWS and Azure. So yeah, you can certainly configure that, and then the second part is the replication. Now for SQL Server, the usual suspects we talked about, the always-on availability groups or SIOS Datakeeper doing the replication, and of course then you can always think about log shipping and just moving backups and that kind of stuff. But for other data, obviously SQL Server is typically only one of many applications. You may have file servers or any other application servers you need to take care of. Datakeeper Cluster Edition is a great solution because it just does block level volume replication from one server to another. So it doesn't really matter what data. It could be SQL Server, file servers, Oracle, any application data you can be able to replicate between sites. So yes, you can set up failover between Azure and Amazon. Just set up the VPN, configure your replication, and there you go.
All right, the next question is about sort of a hybrid model, again, having their primary databases on-prem. And in this case, they're saying they have like a terabyte-sized database. And they're just wondering, how does that work? How does the data get to the cloud? Is there downtime, or how does that whole replication process work? And you can kind of explain that a little bit.
Yeah, any sort of replication is typically not the size of the data that matters. It's really your rate of change. Is how much is that data changing on a daily basis or minute by minute basis. And it's very easy to measure that. Through perfmon, you can collect counters on that. So to answer your question, I guess it depends on the technology you're using, right? So with the Datakeeper Cluster Edition solution, you would set up the initial mirror. You create your network, create the mirror. That will kick off the replication of that database. Now the database is going to be replicated at the block level, and it will take some time depending on how fast your connection is to get all the data up there. But once it's up there, and during that time, the database can still be live, and you can be accepting new writes to it, and we'll just track those writes in the bitmap file, and those writes will be sent as well. So there's no downtime. It'll take a little bit of time to get all the data up there, but once it's up there, then you only ever have to replicate the changes. So you don't have to worry about ever replicating the terabyte or 10 terabytes of data ever again. It'll all be up there, regardless of the size. And that's pretty much holds true for the always-on availability groups as well. You create the initial replica, and it's going to, do the initial replication. You can track the progress of that, and you can still use that database as the replication is being set up.
All right, next question, Dave, is, just read the question as it came in. It says, is a hybrid FCI and always-on configuration supported in the cloud? And they're saying a 2x2 node active-passive cluster with always-on between the two clusters. Does that make sense?
A little bit. So always on is not very descriptive. So always on there's two always on. There's always on availability groups, always on failover clusters. So the bottom line is, yeah, I mean, any configuration is possible. So let's take it like this. Say you have a failover cluster, always on failover cluster locally between two servers, and you want to create, you want to put a node in the cloud and have that as a target for always on availability groups in the asynchronous model. Yeah, I mean that's pretty much the why always on availability groups was created. If you want to extend your failover cluster instance and have a multi-site cluster, you can do that leveraging the Datakeeper Cluster Edition solution. So you can continue to use your shared storage locally, and then put Datakeeper Cluster Edition on the nodes and extend it to a third node in the cloud. I'd say the advantages there are you're getting the entire instance, so all your system databases, your agent jobs, your logins, your passwords, everything is replicated. So you have a true failover cluster, three-node failover cluster with one of the nodes in the cloud. So so both options work. Assuming that you have you're talking about always on, so I'm assuming you have Enterprise Edition, so you'll be able to add that third node in the cloud. Without Enterprise, you use SQL Server Standard, you can still have your two-node failover cluster instance locally, and then just leverage Datakeeper to replicate the data into the cloud, and that gives you data protection, but the recovery would be a manual process.
Okay, great. All right, we've got time for one more question, and then we'll wrap it up. There are other questions, and sorry we didn't get to all of them today. What I'll do is I'll send those over to Dave, and if he has time, he can get back to people on some of these other questions. But the last question for today is somebody was told that they can't set up a cluster on the cloud because there's no shared storage, and and the only option they said was always on availability groups.
Yeah, I mean that's been a source of confusion for many years, and thankfully the final document, which was people were referring to, which was kind of in conflict with some of the other documents, was updated. So there's a link, and if you go, just Google Azure SQL Server disaster recovery high availability. It takes you to a article that's published that talks about how to configure high availability in Azure. Up to maybe 3 or 4 months ago, it didn't really call out the failover clustering as a viable option, even though in other articles about failover clustering, Datakeeper was mentioned specifically, and we've been in the Azure marketplace for a year or more as a certified HA solution. But finally, this last article is updated. So if you have any questions at all, follow me on Twitter. Send me a tweet, send me an email. My email address is here. I'll dig up those articles that, the one article actually mentions SIOS Datakeeper by name. A couple of those articles mentioned it by name as a supported solution for SQL Server high availability in Azure. So it's absolutely supported, but there certainly was some confusion for quite some time.
All right. Well, I want to thank Dave for sharing all his knowledge today, and I also want to thank SIOS for sponsoring today's event. This webcast was recorded, and you'll receive a follow-up email with links to view the archive. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and have a great day.